Bandwidth for changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog.
I'm Jason Keene.
And I'm Andrew Poydence, and this is
Go Time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. Welcome back, everybody, to another episode of Go Time. So today's episode is number 61. On the show today, your hosts are myself, Eric St. Martin. Carlisia Pinto is also here.
Hello.
And Brian Kettleson, who is half alive, half dead.
Half dead.
And our special guest for today, we actually have two, both working on Cloud Foundry, is Jason Keene and Andrew Poydence.
Hey, how's it going?
So I guess maybe give a little bit of background of because Pivotal and Cloud Foundry kind of do a lot of steps. So do you want to kind of give maybe a little bit of background about yourselves and the particular areas within Cloud Foundry that you are focused?
Yeah, so I joined Pivotal about 2 years ago now, and I work explicitly on Cloud Foundry. Cloud Foundry, for people who don't know, is a enterprise platform as a service, similar in style to a Heroku, but it's on-prem. You can also run it in the cloud, on Google or AWS or wherever. So yeah, that's like kind of what Cloud Foundry is all about.
Yeah, I joined over 3 years ago and started on Loggregator, which is the log system for Cloud Foundry, where if you have an application running in Cloud Foundry, your standard out and standard error could be gathered and shipped off to you as a developer. And that's then morphed into also a DevOps perception too, where all the different VMs and stuff are shipping their logs as well and starting to ship metrics as well, so that you can have operators maintain this massive deployment that involves, hundreds of VMs.
And just for like a separation of voices, that was Jason who spoke first and Andrew second, right?
Yeah.
So Loggregator is written in Go?
Yeah, so I would say a good majority of components in the Cloud Foundry system are implemented in Go now. Cloud Foundry has a kind of a history of Ruby, but it went through like multiple transitions where components are kind of incrementally rewritten in Go. So our kind of load balancer reverse proxy component is called the Go router, and it's of course implemented in Go. Loggregator is fully implemented in Go. Our runtime is called Diego. Naturally, that's implemented in Go as well. So yeah, there's a lot of components in Cloud Foundry that are Go.
What led to the moving from Ruby to Go?
I totally wasn't part of the company back then, but I don't know. Do you have any context?
Yeah. So we originally we as in Pivotal, inherited Cloud Foundry from VMware, and VMware had done everything in Ruby. And the DEA, which was the droplet execution agent, was written in Ruby, and it was essentially a giant black box of magic, where everything was written in with metaprogramming and standard Ruby. And so we wanted to add quite a bit of functionality, including like speed, and being able to implement that in Ruby became insurmountable. There were lots of security concerns. There were orchestration problems. And so some developers decided, hey, this would be a great opportunity to rewrite this in a way that would actually be maintainable. And Go was picked because of its simplicity. And so DEA Go, which is Diego, was born, and it's a massively distributed team. It's got contributors all across the country. I think there's people in Europe contributing to it, and it lends itself to that because it was written in Go, and people can quickly jump in, gather context in the part they need to, and start contributing.
Nice.
I would love to talk more about that actually. What makes you say that that's what I might take it on it anyway. My take on what you just said is that because the system is written in Go, it lends itself well for a distributed team to work on. What makes you say that?
Yeah. Some of the kind of insights I have is that it seems like uh, engineers, no matter what their background is, whether it's a dynamic language or a statically typed language like C Sharp or Java, they really feel comfortable in Go. Go is kind of like the subset of it's such a small language that the subset of like the syntax and what is there uh, is kind of like approachable by many different engineers from many different languages. That's something I kind of noticed. We have people on our teams that have backgrounds in Java, people on our teams that have backgrounds in Ruby or Python, and they're able to pick up Go real fast.
The counterpoint, like or counterexample, would be I worked on a Java project for Cloud Foundry, and we had several frameworks. And when you joined the team, you had to get up to speed first with all the frameworks, and then which components use what frameworks where. And so before you could even be successful in contributing, you had to kind of gather all this intimate knowledge about where you wanted to contribute and how that framework interacted with what you were going to do. With Go, since a lot of these things aren't written in frameworks, you can simply drop in, look at the tests that were written, everything is well tested, and get enough context with what you need, and add your addition, make the PR, see that the tests pass, and feel confident that what you actually added will get merged and will be correct. And so like that was a very great experience, and it's enabled a pretty large community across the globe to help us grow Cloud Foundry.
That is something we take for granted, isn't it? That we don't usually use a framework and we don't have that extra thing to learn. Even though, for example, people who come from the Ruby on Rails background, when people learn Ruby, they learn Ruby via learning Rails. That their exposure to Rails was what exposed them to Ruby. But if you go a bit further back and you work with Java, or even PHP has a different frameworks, you really have a bunch of options, and who knows what project's going to use what, and we don't have to go through that.
It lends itself to, I think, enabling people to quickly help without all this extra overhead, and we're not switching between frameworks all the time, much like you would maybe on a JavaScript project.
Mm-hmm. Also, the standard library is very high quality, and it's almost intuitive. Like once you learn one standard library package, like the kind of conventions and like intuition you develop from learning that package translates into most of the other packages in the standard library. So that also helps with like getting people up to speed.
So let's continue on this thread, and I'm curious to know for what's it called, Loggregator.
Mm-hmm.
Do you make use of an external package, or are you doing everything mostly using the standard library? Do you use an external package that has to do with logging?
So we use gRPC very heavily for our transport, but we've kind of homegrown the like metrics and logging concept. So we have something called envelopes, which are actually protocol buffer messages that encompass a log message as like textual information or a counter event or a gauge metric. And so we enable like components or applications that can then send these things. And the application is at the moment tied strictly to standard out, standard error. And then those things get packaged up into these protocol buffer messages. But we're not actually using anything off the shelf per se. In fact, like Loggregator was incepted, I believe, in 2013.
Yeah.
And so it's pretty old. And a lot of our stuff around that has to kind of deal with the fact that we have this very old Go project where Go wasn't as heavily adopted back then, and there were a lot less tools available to us, and we had to kind of think about how would Go want to approach this. And in fact, we were at that point integrating only with the DEA, which again was written in Ruby. So we kind of had to make these interfaces clean that could be consumed and used from many different languages.
gRPC is a great reason to do that.
Exactly.
I was going to ask, do you find yourself having to rewrite stuff that you wrote way, way back in Go?
Yeah, we I would say a large portion of the Go or the Loggregator Go source code has been at least heavily modified, if not rewritten at this point. It's an incremental approach that we've had over the past 2 years. As a need is put on us from a product perspective or an engineering perspective, like we then decompose what's there and like try to, bring new ideas and new implementations like into the project. And we've done that with several of the components. So yeah, I would say we've done a good amount of rewriting, but it's rewriting that's informed by a lot of different variables. It's not just engineers wanting to rewrite something.
Right.
Mm-hmm. And these variables, can you give us an idea? Because it's very interesting to talk to somebody who has been working with one particular project for so many years.
Mm-hmm.
And, we're always trying to take insights for people who are listening that they can pay attention to and maybe use in their own work. So I'm curious to know what sort of variables, what sort of ideas are guiding rewrites, because obviously you're saying you're not just refactoring for refactoring's sake, which is great.
Yeah, I guess I could give like one of the examples of something that we've rewritten is we switched over to using gRPC. It was about a little over a year and a half ago. And that was kind of motivated from an engineering perspective. Like we wanted to reduce the cost of us maintaining our own custom messaging. So previous to using gRPC, we had our own custom TCP framing and TCP batching and UDP code for managing messages. We also use Gorilla WebSockets, and we had this hodgepodge of different transports. So from an engineering perspective, we wanted to do this rewrite. And what kind of motivated that was security was one of the major motivating factors. So gRPC gives us mutual auth TLS, which is a awesome feature to have for doing secure communication between different components. And we get that as a feature. And as part of that, we get to also kind of reduce some of the technical debt on the project and do a rewrite of our message transport.
Very cool.
One of the other big drivers has been the growth of Cloud Foundry. Before Cloud Foundry probably was only handling a few dozen apps at a time. And now you have larger installations of Cloud Foundry that have upwards of like 250,000 app instances running, which means all those apps are trying to stream data through Loggregator. And we noticed that some of our previous code just wasn't up to the task. And so as these larger deployments have come out, we wanted to be able to handle all that log load. And so we've had to invent a few things around that and better understand what it meant to handle that many messages a second and large dynamic payloads, and like just many, many consumers that are trying to get all those payloads. So a lot of stuff has just been slowly vetted out by having Loggregator installed in so many different companies' data centers.
Mm-hmm.
So that's actually a really interesting thing. Like, so what are some areas that you ran into, like you kind of alluded to, like where you had to invent some things to solve for problems that you didn't experience without having that additional scale? I'd be really interested to hear about kind of some of those things that you ran into and the things that you had to create to work around those issues.
So the big one we ran to first was Loggregator has an agreement with app developers that when you log to standard out, it won't be slow. In fact, it won't push back at all. It should be free. So Loggregator has the task of ensuring that while we do our best to push messages through this distributed network system, we will not push back on the application. So we use channels, obviously, for distributed data. Go has those, and they're great. But what we noticed was, as you write to a channel, and that channel can't receive any data because there's downstream latency, we wanted to not drop the new messages. We'd rather drop the old messages. So now you have some kind of complicated thing instead of just your normal, like writing to a channel with a select and a default, because those would drop the new messages. So we ended up making something called a diode, which essentially was a ring buffer that operated purely on atomics and would therefore prioritize new messages over old ones. And this enabled us to have buffered data, allow for network latency, and recover from that, while ensuring we didn't push back on consumers, or producers rather, and still trying to get the most amount of logs we possibly could to our consumers. So we went and ripped out a lot of channels that we previously had before to enable kind of like less buffering, fewer go routines per connection, and a little less latent end to end.
This is open source, isn't it?
Of course.
Yeah. So Cloud Foundry is an open source. If you go under github.com/Cloud Foundry, all the components of Cloud Foundry are listed under there, and you'll find these libraries that we're talking about under that org as well. One other thing that came to mind when you're mentioning like what type of technical limitations that we ran into that we had to kind of step back and like think of like ways of getting around is we used to use WebSockets pretty heavily between certain components. And while you can multiplex like multiple messages, multiple streams of messages across a single WebSocket connection, it's not typically like the typical use case. And so a lot of our like legacy code that uses WebSocket protocol was dedicating a single WebSocket and thus a single TCP connection for every single stream. And like naturally, that's going to limit your ability to scale. So that was another like huge win that we had with gRPC. Since it uses HTTP2, you get pretty much for free multiplexing of multiple streams across a single TCP connection. So we did a little bit of work around that. We got the multiplexing for free, but then we also noticed that sending all of our streams over a single connection, it actually like saturates that connection. So we created kind of pools of connections and load balancers to kind of manage that, so that we can have many streams going over many connections and just have it all work in an efficient way.
Very cool.
So now, are you using your new diode concept throughout other portions, or is this mainly kind of limited to just Loggregator?
So recently, we've had some downstream consumers of Loggregator start to use it. So Google maintains a stack driver nozzle, which is a component that reads off of our fire hose, which is like all the data coming out of Loggregator. And we're pretty aggressive about killing consumers that are reading slowly. If we detect that you're not reading fast enough over a certain period of time, instead of like dealing with the costs in our system, we just close that connection. And let you know you got to reconnect. So they were seeing a lot of these reconnect events, and they were panicking on these reconnects, which is a little bit inefficient. So we kind of had a conversation with them and introduced them to the diodes, and they've been able to use that to prevent themselves from getting disconnected by the Loggregator system. Trying to think of some other projects I noticed recently adopted it.
There's a few closed source ones in Pivotal that use it pretty heavily.
Yeah.
So
I thought there was like another open source project recently. It doesn't come to mind, but yeah, it's mainly kind of Cloud Foundry ecosystem, Pivotal stuff so far.
It's written in a way though that it certainly could be used.
Yeah.
Anywhere.
Yeah, we tried to the Cloud Foundry project. At least I'll speak for Loggregator. Loggregator hasn't had a really good history of extracting useful things for broad consumption. So the diodes is like kind of one of the first projects that we started that where we extracted this idea out so that other consumers could use it.
Now, I'm reading here that one of your project goals is to have an opinionated log structure. So talk to us about that. So at the very least, I've never used it, so I'm guessing it's a you offer structure logging. And why is that the best goal for this project?
So we took the approach that there's textual logs, like an application can emit, just normal standard output stuff. And then there's metrics, such as counters or gauges, timers, much like you'd find in a project like Prometheus.
Mhm.
So what we did was we decided we'll make these protocol buffer messages and have them be very strict about what they'll accept. And the idea would be any producer has to put those fields in there. And that would enable then the consumers of Loggregator to know what they could get. And that has enabled a lot of nice things because all of a sudden these very generic consumers can come in, such as the stack driver one, and not know very much about Cloud Foundry as a whole, this massive system, and yet still can pull in and do very interesting things with the data. And so it's been like a nice way to document how metrics flow through Loggregator without having to dig through massive amounts of readmes and go through different components as to what they're trying to accomplish. And it enables the compiler essentially to do more work for you as well. You can't accidentally send some invalid protocol buffer message that will get rejected.
Mm. How many fields are there?
It's pretty limited.
Yeah, so there's a repo called Loggregator-API, which is just our .proto files that we use to generate our clients and everything off of. If you want to take a look at it, it's pretty conservative. We have a V2 API that we started on about a year ago, and that V2 API kind of took all the lessons that we learned from previous iterations and kind of distilled like the core set of things that we needed in the envelope and in the individual messages.
Our hope is that we have perhaps distanced ourselves away from being specific to Cloud Foundry. There's a lot of neat things happening everywhere, like, for example, Kubernetes. And what we don't want is to have the Loggregator system be so opinionated that it would only be useful within Cloud Foundry. So Loggregator is doing its best to be a distributed logging and metric system for several distributed systems and not just Cloud Foundry. We had our original iteration where everything was specific to Cloud Foundry. Every metric type was something that only Cloud Foundry could ever care about, and the consumers would only ever care about Cloud Foundry. And what we noticed was other interesting distributed systems were coming out, such as Kubernetes, and Loggregator was in a technical position to where it could service these things, but we were so opinionated about Cloud Foundry, we really weren't putting ourselves like in front of that. So we decided to move our API more towards a generic place and have generic metrics with a subset of the information we previously had that would be useful, therefore, for any different number of distributed applications and enable distributed applications to use Loggregator to optimize their apps or maintain them, do DevOps work, and just ensure that like iterations are happening. So Pivotal's main focus is to enable developers to do interesting things. And so Cloud Foundry wants to enable developers to do, hard, complex distributed systems and maintain them and iterate on their software quickly and have confidence that their stuff is actually working. So they need visibility into that.
Now, here's kind of a random off the wall question. How complicated is a Cloud Foundry install? Is it something I could put on my laptop? Or do I have to have a minimum number of VMs to run it or a minimum number of physical nodes?
It scales down pretty well. There's a project called Bosch deployment. So we use Bosch to manage the Cloud Foundry deployment. And so you can run Bosch deployments locally on your laptop. We do it on our Linux workstations here for development purposes. We'll deploy Cloud Foundry. Granted, it's a trimmed down version of Cloud Foundry. It's not completely highly available, but you can run that on your laptop as long as it can run a decent sized VM.
Yeah, there's a project that's called Bosch Lite.
Yeah.
Which essentially, I mean, I don't think it's even called that anymore, but we still call it.
Bosch deployment is like the new like project name for it,
Right.
And they have a VirtualBox kind of CPI for that. So
Right.
CPI is a cloud provider interface, which is a Bosch term for basically how Bosch speaks to a cloud API.
I don't know why I just caught that like you're saying Bosch, but like when you say it with deployment, it sounds to me like botched deployment, and I kind of chuckle.
Yeah,
I've never heard that. That's perfect.
That's funny.
I think Bosch was actually supposed to be, and I think we all have our like giggle and opinion about it, but it was supposed to be Borg, Google's Borg plus plus. So it's like R plus is a S and G plus is a H. So
Yeah,
Bosch.
It was conceived in a time when like this is well before like containers were popular or even known about generally. So yeah, it operates more on a VM type concept. So it's good for doing deployments. It's similar in character to maybe like a Terraform, but it also has some like monitoring abilities. It has an agent that runs on all the VMs. It manages your stem cells, which are the images that the VMs boot up with for security reasons, and manages the packaging of the software that gets installed onto the VM. So yeah,
it's a handy tool.
Yeah, it's incredibly handy.
Now, for someone who have been working with this project for such a long time, I would like to ask the question: if Go had generics, would it be more useful to you? Do you miss not having that, or do you get by without it? Would you recommend the standard library adds it?
Yeah, it seems kind of like a trolley question. Like I kind of have the opinion that Go, if it had generics, it'd make implementing some of the data structures that we've exposed, like, for instance, the diodes, like much more natural. I don't know what your opinion is.
Yeah, we kind of get around it. So, for example, the diodes operate on unsafe pointers. But when we bring it into projects, we immediately make a wrapper around it with the actual type that we want to be in the diode. So that way we get the benefit of the compiler. But that's something that is kind of hand rolling, maybe like a C++ template or something.
Yeah, and the wrappers are for like something like diodes. They're easy to generate, just kind of boilerplate code.
Right.
So you can use Go generate to generate those. So I mean, like Andrew said, we kind of worked around it. I'm happy with kind of the pattern that we've adopted to make our stuff generally usable. But it does mean that you have to use things like empty interface and unsafe pointer. But we kind of contain them in a small box so that it doesn't bleed out into the rest of your program.
And I think that's been really key for us again on like this massively distributed team. If you let your unsafe pointers or empty interfaces leak too far, again, if someone were to just drop into the middle of your code base and try to help, they wouldn't have the compiler helping them there. Like, what is this empty interface? What is it supposed to represent? How am I supposed to know?
Casting of unsafe pointers is not always intuitive, and we've had situations in the past where sometimes like putting an extra asterisk, the compiler doesn't tell you, hey, this is dereferencing something you shouldn't dereference.
Right.
So yeah.
Mm-hmm. Did you make a proposal to the Go team?
Implementing generics is well beyond my expertise.
No, because there were soliciting use cases, not a proposal for how to implement, but a proposal like here's my use case, because they were soliciting it. I don't know if you know.
I wasn't aware of that.
I think before kind of approaching a solution or something, they really kind of wanted to be well aware of the types of situations that people were looking to use generics.
Sounds like you guys have a good use case.
Yeah, we could throw it out there.
Yeah.
Go-to type stuff.
It's my go-to complaint about Go. I don't want generics, just for the record. I like my Go readable, and I think generics will make it worse.
Coming from a C++ background, I get nervous.
Yeah.
Just have nightmares when I have something where like boost messed up and I
Nested
had,
angle brackets.
yes, pages
Yep.
of compiler errors.
Uh,
I think it could potentially make life easier for 20% of the users and harder for 80%. So I'm not crazy about it either.
yeah, I'm not saying that there aren't use cases for it, particularly use cases that would be much easier um, with it, but I don't find working around it overly difficult. But maybe I don't work in the spaces where it would be the most useful. So I'm not against it, but I'm not like the language is broken without it.
Yeah, that's why I like the idea that I like the fact that they were soliciting use cases so they can get everything together and just make a decision. Because I don't know every single project out there, right? I mean, we don't know.
Yeah, I'd caution like listeners if you are going to use like empty interface or some of these other generic types to approach it in a similar way that kind of we approached it, contain it within a small area of your code base so it doesn't bleed out to the rest of your system. I could drop a link in this show notes for like how we approached it, just so that people can kind of get a feel for what we've done.
That'd be awesome.
Yeah, we made a few libraries, and I think we've run into this a few times where it's like I guess we make it an empty interface and then try to do our best to make sure we don't use it as that. But again, like it's so easy to work around. I don't think that I wouldn't be driven to like say that the language is broken. I'd agree with that, and it lends itself to be fixed.
I'm definitely like appreciative of the consideration that the core team has when it comes to generics, because like you were saying, like we don't want to be in a situation where 80% of the engineers are having to deal with this frustration of like massive compiler errors that are nonsensical, just to serve like a niche, 20%.
And the ways to work around it are kind of fun too. Like Brian here is like the king of code generation.
We could use some of that, I think. Yeah. We have one library that does its best to generate a tree traverser for you, which was a very interesting problem, but generating code is hard.
Yeah. Especially like code that like mortals can read.
Yeah.
That's what makes it fun. It's like leveling up your code skills. When you get into code generation that's generating code, then you're hardcore.
And you know you made it.
Next level.
Yeah.
And that might be too many levels deep for me. It's like, wait, so does this code generate the generation code or the generated code?
Generates itself.
Yeah, it's like a quine that just generates itself somewhere in the middle there.
I guess it's not new too. You've got like GCC and stuff that bootstraps itself, right? Or it compiles itself to compile itself.
Right. Insane.
So that the new version of GCC's compiler has the optimizations that came with the new version of GCC. It's just kind of funny. So, you mentioned in the docs and stuff too, gRPC, that you guys are using that, and kind of went through some experiments with other forms of messaging. Uh, how long ago did you land on gRPC?
So yeah, we picked up gRPC shortly after 1.0 of gRPC Go was announced. It was in the news, and we're like, oh, maybe this will serve our use case. Previous to that, we were kind of looking at 0MQ, NanoMessage, Mangos, this type of messaging frameworks. What really like sold us on gRPC Go, well, it was like a multitude of things, but the fact that there was a really solid native implementation in Go was a big win. We didn't have to use CGO to talk to some C library to do our messaging. Again, like we kind of started playing around and we noticed how easy it was to get mutual opt TLS like off the ground. It's really, really simple API that they have. You just dial up and provide your certs and keys, and everything just works. Previous to that, we were kind of like hand rolling some of our own mutual TLS. And while the TLS library and standard library is pretty solid, there's some like kind of gotchas and rough edges. So gRPC kind of handles all that for you. we were kind of already using protobufs, so it was a natural fit. With gRPC, you generate all the clients for all the different languages that it supports. So that was like a huge win. We wouldn't have to maintain a lot of clients. They would just be generated. And I think that's about it. There's some other reasons why we kind of adopted it.
Yeah, it's also really good at upgrade paths. So Cloud Foundry has to be HA, like above all things. So upgrade paths are always something that we're considering. Every change we make, we'll talk about how will this upgrade from a previous version? How long can we keep this thing before we can deprecate it, or how long do we have to keep this thing before we can deprecate it? And gRPC does such a solid job at upgrading, even when it has its own updates. It does it. It considers that as well, and it had the kind of that backing, which was huge.
Mm-hmm. I mean, that is something that when you're using gRPC and protobuf for that matter, you kind of have to consider like your upgrade paths. It's something that you have to spend some time like considering. It's not something you get for free, but it definitely like provides a clear path for you. And it's something that you can tell the people who created gRPC in protobuf. It's something that they are concerned about, having these smooth upgrade paths.
Right, because when you get to like the actual protocol that things are communicating over, it's extremely hard to change it because then everything basically has to come down and back up at the same time unless there's kind of like well thought out upgrade paths.
Right. Yeah, that's not a thing in Cloud Foundry. We have Loggregator has components, an agent that runs on every single VM in Cloud Foundry. So for us, like we have, like there's customers that have deploys that go for days because they're rolling so many VMs. So your VM that rolled, from the beginning has to still be compatible with the servers that won't get rolled for a couple more days, type of thing. So
that's crazy. Multi-day deployments.
Yeah, unfortunately, there are some war stories of multi-day deployments with massive, Cloud Foundry deployments.
Yeah, just enormous data center upgrades and stuff.
I feel like I've gotten spoiled. I was trying to deploy a Kubernetes cluster with single command the other day, and I was getting frustrated. It was taking minutes.
This deploy took 8 minutes. It's a bug.
Yeah, I mean, some operation teams kind of appreciate the slow, methodical approach. They're not as impatient as us developers, so they prefer a stable system that upgrades cleanly and without incident than a system that upgrades quickly with massive incidents. So yeah,
operations people.
Yeah.
How dare they want stability?
It's tricky.
We could have like a crazy show if we just had an ops person on and we just fought back and forth.
Fight me. Run fast, break things. That'll be the title of our show.
It's amazing that there's still kind of two camps, like even with DevOps kind of being a thing, there's still people kind of fall within two camps. And it's kind of the question that I always ask people is, if you have a production system that has say a memory leak, and restarting the process will fix the problem, but you will lose all forensic evidence in order to debug the issue. What do? Do you restart the process and resolve the issue, or do you poke around and get heap dumps and stuff like that? And usually you'll fall within one of the two camps. Either you'd be like, no, we need to debug this, or no, we need to restart it and bring uptime back up. So
well, I think you left out what impact it's having on the customer too.
Yeah, obviously there's a lot of variables there.
Yeah, I mean, because if you could take the server out of rotation and let the other nodes handle it while you poke at it.
This is more like a hypothetical situation where I'm sure many other people on the call have been in situations in prod where you got to bring back the service, but it's kind of a hypothetical situation where you have to make a choice either or.
Well, usually a lot of us developers, it's we get an email that they have already restarted
Yeah.
it, and you're like, but,
And then you're instructed to go fix the problem.
you're just combing through code, looking for anywhere that could leak memory.
Something happened in prod. We don't know what. Fix it.
So, but yeah, I mean, I think we're still trying to find the perfect balance between ops and dev and things, right? And I think a lot of the initial motivation, at least from my standpoint, for the whole DevOps movement is to understand how your code would be deployed and to um, help deliver your code as a full-fledged product with the tools that the operators need to support it and the documentation for how to handle these scenarios, how to figure out when it needs to be restarted, things like that, instead of just taking this, new build and being like, here, you make it live. But whether developers go full-fledged operations, I don't know whether that's the right mix. I think we're still figuring that out. It's still early, but I think it does make sense for us to have some operations knowledge.
We on Cloud Foundry have embraced that pretty heavily through Google's SRE, that book they released not too long ago.
Good book.
And
Yeah.
I
yeah,
still need to read it.
It's a very like light read.
I got some playing time this weekend, so maybe I'll start.
it's fantastic though. We've there's a lot of things that are common sense, but it's nice to formalize it. And then as a team, you can kind of use it as the decision maker. How
Yeah.
should we approach this? Well, how would SRE have done it?
Yeah, it gives us like a shared vocabulary now. So like we're referencing the same concepts versus before you kind of have to build up that kind of shared vocabulary.
Right. The other interesting thing that we have here at Pivotal, working on Cloud Foundry, is not only are we running in hundreds of different data centers, completely different configurations everywhere, but we also have our own massive Cloud Foundry running, run.pivotal.io, that we're like on call for. So we often will push something out there and we'll know pretty soon if what we did was a big mistake or not, because our local Cloud Foundry that's running this, has running thousands and thousands of app instances. All of a sudden, you had a memory leak, like Jason described, and you're getting paged in the middle of the night, and you see that you have some kind of linear climb in your memory usage across the servers, and you kind of have the cloud ops team saying, "What do you want us to do?" So it's kind of always an interesting thing how quickly you can have a bad decision come back and get validated as such.
Yeah, kind of speaking about like operation stuff. Like we're all software engineers, so we don't really kind of get into the operation stuff very heavily. We are on call for our production environment, but like recently, as part of like our partnership with Google, we went through a CRE, which is their customer reliability engineer program. We went through a review for Loggregator, and there's a lot of kind of operational patterns. Like some of them are things that I've heard like Kelsey Hightower speak about. It's like sympathy for your operators. So they came to us with some of these like patterns that they wanted us to add to Loggregator. It's stuff that like we maybe have thought about tangentially on occasion, but they really like pointed it out to us. Like these are things that you should have to have a certain amount of nines of reliability.
The nines reliability has been really nice. How to measure success on a distributed system is kind of a tricky concept. It can seem like it's working to you, but then you have a different consumer that they're not getting what they expect at all. And how do you kind of measure how everything's going?
Yeah, and then I think you have the flip side of it, which is anytime you give somebody a metric in which to measure something, it has to be 5 nines. It has to be 100% test coverage.
All right.
Yeah, that's one of the things the CRE guys kind of pointed out really early is setting your SLA and SLIs at the right level. Having 4 or 5 nines is not necessarily something you should strive for. Having a lower level of reliability gives you more flexibility in how fast you can iterate, and has other advantages. So it's kind of like setting the right expectations and meeting those expectations.
Then I think when you talk about reliability or security or any of those things, it's always trade-offs, right? Like you can't focus all your time and money on all the areas. There's just not enough time. You have to look at like what the likelihood of this failing or being compromised is, and then you have to look at what the impact of that happening is, and then that's how you categorize the things you spend the most time on.
The SRE book is such a good read for that because they talk about having a budget. You're all of those nines are just digging into a budget. You've got a budget for downtime. How are you going to use it?
As like a streaming service, like we kind of measure things a little bit differently than a typical like request response type service. So we measure how many nines we have of message reliability, which is basically how many messages we drop. So we don't give hard guarantees of durability or delivery. So we want to make sure we're doing our best at that. But it's something that under certain situations we will drop messages. So that's kind of one of the primary metrics that we look at for our quote unquote error budget. These aren't actually 500s that you're getting back from a server. These are just happen to be missed messages. And the way we test that is we have a pretty aggressive like kind of black box testing of our system. So we have various environments that are running our software, and then we kind of probe it from the outside and ask for a specific quantity of messages. And based on how many we get, that gives us our amount of messages that we've lost, and we run that constantly on these different environments to get a signal of like a message loss.
So I think we've got a few minutes left. So we should probably jump into projects and news and Free Software Friday and all of that good stuff.
It was kind of a quiet news week, wasn't it?
Yeah, I don't know about a whole lot of news. I mean, mostly like product releases and stuff like that, like Heptio. If you are a Kubernetes and Envoy fan, they just released something called Contour, which basically allows you to use Envoy as the ingress controller, which is super cool.
Written by the legend Dave Cheney.
Yes,
Legend.
he was pretty excited about it too.
I forget that they've trained you as a have to.
Yeah, yeah, that was a kind of exciting couple of weeks where everybody was trying to guess where he was going.
Mhm.
Microsoft.
That would have been cool.
It's a great attractor in the Go community. Everyone's gravitating to Microsoft.
I hear all the cool kids are going there.
Yeah.
Maybe we can get a job there.
I'm not good enough.
So maybe we can keep our job there. So another cool project I came across was called Go TTY, which I've only played with a little bit, but it seems super cool. Where you basically can share your terminal, but through like a web page, so everybody else kind of gets to hit a website and live view your terminal.
GoTTY is really awesome. I've used it to back a couple projects that I wrote this spring, and there's a lot of power to it. You can pipe it through to just about anything. I had mine piped through to Docker so that when somebody hit a web page, it would automatically spawn a Docker container and drop them into a shell. So you had web-based containerized shell environments for everybody using GoTTY.
I didn't even realize that you had used Go TTY for that.
I've touched everything, Eric. You should just accept that.
This is really cool. Very useful.
Another one that I came across is called GERT, and I think we mentioned this before. I think it might have been a little earlier on, but it seems to be a port of the Go runtime to run directly on ARM v7 system on a chips. And I haven't got to play with this yet, but maybe when I get back from traveling, I will find an ARM7 device and try to do this.
It sure is looking good, though.
Yeah, I mean, and they already have support for most of the serial protocols and things like that, SPI and UART. I don't know whether I saw I2C supported yet, but that will be really interesting.
Is that how you say that? I squared C? I always read I2C, but it's
Y-
because I don't know what I'm doing.
Yeah, I think yeah, I think people say it both ways, but I think it's technically I squared C.
Nice. Today I learned.
We need the more you know. Do do do. Another cool tool that I came across is called Ghost Scan, and it basically scans the IPv4 subnet range and uses Samba and things like that to discover host names. I've been noticing more and more like security tools written in Go, which is really cool.
When your worlds collide.
When my worlds collide, yeah, because most of the time when I play with security tools, they're written in Python or very bad C. That happens too. And like
Isn't that
people
kind of
love,
ironic that people write bad C for security tools?
yeah, that is true. So another cool one that I actually just saw today was gomatcha.io. And it seems to be a project that has bindings for Objective-C and Java so that you can write your mobile apps completely in Go. And I have not tried this yet, so if you have, please like find me and tell me whether you like it or not, so that I can build something with it. I'll let other people be
Yeah, somebody
the
else go try
testers.
that. We have a couple big conferences coming up this month. .go and Go for Con Brazil. I'm getting on a plane in 21 hours for .go.
Is anybody here going to DECO?
No.
Not
Well,
me.
Brian is. He's speaking, but I didn't know if anybody else is. Yeah, you're speaking, right?
I am.
And then we have the following week, or maybe it's 2 weeks later, mid-November is Go for Con Brazil, which I
Yeah.
know Carlicia will be at. She wouldn't miss it for the
Yeah.
world.
Yeah, I leave on the 14th,
Nice.
and the conference is that weekend. And I'm speaking,
Oh, you
supposedly.
are
That's
speaking.
awesome.
Yeah.
What's your topic?
I'm going to talk about certificates and TLS and Let's Encrypt and
Very
Go,
nice.
of course.
Oh, nice.
I don't know how I did it, but I managed to sign myself up for 5 talks in 11 days. And I am 1 talk into that 11 days and already regretting the whole plan. I think it was Eric's idea.
Are they all 5 different talks?
They are all 5 different talks.
Wow.
I was bright enough at least to write sample code for 3 of the talks in one repository. So one of the talks is on microservices, another is on open tracing, and then there's another on something else. So I built a bunch of microservices that had open tracing, so I could at least use one group of code for several different talks. But oh my gosh, regret.
Yeah, I don't think I could do it.
Yeah, it's like an ultra marathon of coding talks.
I'll take the blame though.
I wish they were all local. The hard part is that it's .go on the 6th, and then the Women Who Go in Paris on the 7th or 8th, and then Code Motion in Italy. So much flying. That almost sounds whiny. I am really, really grateful to be able to get to do the job that I do. I'll be quiet now.
So, one other cool thing that I came across was actually in NVIDIA's GitHub organization is a project called NVIDIA Docker, which is supposed to have support for having containers that can leverage NVIDIA GPUs that are running on the hardware. So that will be really cool to start seeing like CUDA applications running inside containers.
All right, how about some free software Friday?
I'm in.
Mm-hmm.
So I'll start it off because I already whined about all of these presentations. I'm going to shout out to the present tool from the Go team. I sure love being able to write my slides in a very light format and just typing present on the command line and getting good looking slides that are easy to read and easy to write. So thanks to the Go team for making the present tool. I use it for pretty much everything.
Hey, can you play a video inside the present tool?
You can play videos, you can put
Hmm.
iframes in, you could do everything. And I forked the present tool, and in mine you could run Docker containers and all kinds of extra stuff. 'Cause
Really?
that's how I roll.
Hmm. Okay.
Have you changed like the color format or anything? Because that's the
No.
only thing I think that's hard with the present tool sometimes is like meetups and stuff are good, but like sometimes like in large rooms like towards the back, the black text on the gray code bubble like becomes really hard to see.
It's really easy to change, but I've never felt the need because I don't pay attention to, things that look pretty or not pretty. That's just not my world. That's why I'm a back end developer.
Carlicia, did you have one this week?
Yes, I want to give a shout out to not a project, but to a person, Francesc Campoy. He is leaving Google, and I know he was working for as a developer advocate for Google Cloud, and also on the Go team, right? I think he worked in both groups. So I was really sad to see him move on. I don't know why, because he's been there since I knew of Go. But I think it's going to be sounds obviously I trust his decision. It's probably a very good transition for him. He's going to be I think he is already or soon to be the VP of Developer Relations at SRCD
Yeah,
underscore
Source D.
source
Yeah.
D.
Source D.
I'm trying to read, which I never heard of this company before, but they sound really cool.
They are awesome, and he's going to be a great fit there.
So good luck to Francesc, and yeah, hopefully he will stick around. He's done so many things for the community. He went way and beyond his Call of Duty.
And just FYI, Source D is not the Society for Research in Child Development. This is a completely different Source D.
Thanks for clarifying, Brian.
Sure. You bet.
Very helpful.
Jason, Andrew, do you have any good software?
Yeah, I have concourse.ci. It's the CI and CD that we use here on Cloud Foundry real heavily. And it's just a super valuable tool to help get any commit you want out there quickly. And we run our tests with it, use it to push to production environment and everything. So it's all written in Go. It's something you could run in your own data center. You could run on your own VM or, yeah, it's been a real valuable tool that they've worked real hard on.
It's not a paid service, right? You get the code and run on your servers.
Yeah, exactly. You can bring it behind, to an air gap data center if you need to, or run it wherever.
Mm.
Yeah, it's kind of sweet spot is doing pipelines. So it visualizes the pipeline really well and allows you to chain different, jobs and tasks into different, other jobs and tasks. So, whatever your build artifacts, Docker images, or whatever it may be on the other end of your pipeline, you can automate all that using Concourse. It's really nice.
Oh, that's awesome. Another thing to add to the list of things to play with that I don't have time for.
Mhm.
So yeah, I had a free software for everything as well. So this is about the coolest thing I know going on in the kind of realm that I work in. So we work a lot with metrics and performance measurements. And there's a kernel technology called eBPF, which is a virtual machine. It's an actual bytecode that you can write that runs inside the kernel space. So there's a lot of tooling around like creating and compiling these programs. So GoBPF is the bindings for libBCC, which is a compiler that compiles down to the BPF bytecode. So it allows you to kind of write Go programs. You have to write a little bit of C that gets compiled into the kernel, which is the kernel space part. But then the rest of the program can be in Go, and it's a pretty nice tool to be able to have high performance monitoring of either your user space or your kernel. So you can reach out and do K probes, U probes, trace points, things like that.
Oh, that's awesome. Yeah, I've actually used BPF before too. So I didn't see that somebody had done Go bindings, so that's awesome.
Yeah, the Python bindings are kind of the reference ones that a lot of people use, but the Go ones there, one thing you just have to make sure is that the version of Go BPF that you are using, you have the appropriate version of libBCC, which is a dynamic library. So you just got to make sure you have the compatible version. It's one like hiccup I ran into early on.
So mine for today is dep. So we've all kind of talked about dep, and Sam spoke about it at the last GopherCon, but I actually hadn't worked on a project that used it yet until recently. So I definitely want to give all of the people who have put so much effort into that a huge shout out, just because it's quickly becoming my favorite vendoring tool.
Yeah, I've been using that too. It's been good. I like it.
I've been using dep a lot, and it makes me happy.
But you guys were using their Cloud Foundry.
We early on we kind of experimented with dep. I think it was before it was something that was promoted as like generally usable. So we don't actually use dep. We run all of our source code against the latest dependencies, like their default branches, and then we vendor dependencies using Git submodules. It's kind of a legacy technique, but it served us well. So
It's old school.
yeah.
Respect.
All right, so I think we are out of time, but I want to thank everybody for coming on the show, and definitely thank you, Jason and Andrew, for joining us.
Yeah, thanks for having us.
Yeah, thanks for having us.
Yeah, thank you.
Is this the first time we've successfully had two people at the same time as guests?
Yes.
I believe it has.
I want
been.
to say we tried it once and it was a massive fail.
I
Yeah,
don't
I
remember
need to
us
consult
trying.
us.
That's why we don't do it.
They did say they were pros, remember?
That's true. They did say that. Yeah, but their audio went out in the middle of the call, so I don't know if I'm buying the whole pro thing.
I'm blaming Skype on that.
Okay. Yeah, Skype will take a hit. All right. Thank you, Jason and Andrew, for coming on.
Thanks.
Thanks.
Thanks. This was great.
Thanks everybody for listening. You can follow us on Twitter at GoTimeFM. If you want to be on the show or suggestions for topics or guests, file an issue on github.com/GoTimeFM/ping. And with that, goodbye everybody. We'll see you next week.
Bye.
All right, that's it for this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. Also, Linode. We host everything we do on Linode servers. Head to linode.com/changelog. GoTime is edited by Jonathan Youngblood, and the theme music for GoTime is produced by the mysterious Breakmaster Cylinder. We'll see you again next week. Thanks for listening.
My name's Jason Keene.
And I'm Andrew Poydence.
And this is Go Time.
Go Time.
Okay, we didn't sync up on that one. I'm Jason Keene.
And I'm Andrew Poydence.
And this
is Go Time.
Okay.
How about you just do it?
I'm going to signal. I'm going to give you the hand signal. And then
All right.
We'll do it in that. I'm Jason Keene.
And I'm Andrew Poydence. And this is
Go Time. We didn't even sync up on that.
You just say it.